3, 2, 1. Right. We are moving over to the future. We're moving to the future. And the future, as they say, ain't what it used to be. So in order to forecast the future, the best way to get a handle on the future is to basically assume it's going to be the same as the past, unless you know something really special. So just to get us in the ballpark, we are going to use, that's why we've got all this historical stuff. We're going to use a median. We're going to use a median, which is like an average. It takes the guy who's right at the middle, and it doesn't suffer from outliers. So, for example, when I look at my cost of product sold, I've got 77 and 74s and 76s here. The median is going to line all of them up in order, and it's going to take the average between the 5th and the 6th one. That's the median. If they're an odd number, then it will take the one right in the middle. So the funny thing is that I am applying the median to 10 years time, to June 2029. That's quite unusual. We were sort of maybe thought that we should immediately apply the medians. But what we're trying to do is to build up a normalized case and a normal column, because in order to forecast things, we are going to break our model into two pieces. It's going to have a near-term model, which is going to be the first 10 years. It's going to be the sum of all our first 10 columns. But then we need to get from year 11 to year infinity after that. And we're going to use a technique called terminal value, where we're going to take the value in 2029 in our 10th year, and we are going to turn it into a perpetuity. We're going to perpetuitize it by dividing by the cost of capital minus the growth rate. That's also known as the Gordon growth model. So let me show you a picture, first of all, what we try and achieve here. So this is a blackboard drawing that I drew, and it's broken up into, down the middle here, this is historic, and these are forecasts. And I'm busy talking about some ratio, inventory over sales, for example. And look what's happened. In the past, I've got minus 10 years ago, it was like 4%, but things are been getting worse and worse. And right now we're on 12% of our sales that's in inventory. That's bad. So it would be wrong of us to project and say that, we should just take this through at 12% forever, because we know that that's just a point estimate. It's our very last and latest one. So we're going to use a median of the 10 years, and that'll give us a better number here, maybe something in the middle. But something we don't want to do is to say instantaneously, next year, the first forecast will have that median already achieved. But it'll go from where we are currently, our actual, down to our first year forecast will be there. That's not how it's going to happen. Typically, these things, if they go stray off the mean, too high or too low, they will revert, they will regress back down to that mean. And so we want to build a model that takes us down to the median. So I'm putting my median right down there on the 10th year. So that's why you saw me in my spreadsheet, you saw me calculate my median of those 10 historic years, and I place it into my 10th year. And I do it for most of these things. Most of them, they all look the same, and you'll see it's the median. But somehow I've got to get from, let's take this one, I've got to get from 20%, our SG&A, we've got to get it down to a median of 18.4. So I'm going to suggest that we're going to use linear interpolation, draw a straight line from where we are currently, our current actuals, down to our normalized final year, And so the way we're going to do that, we know we've got 10 times, 1, 2, 3, 4, 10 years to get us down here. So we could subtract off the difference between the median and the actual. So that's the forecast 10 years, okay? The minus the actual one will give us this distance. That's forecast 10, that's actual 1. Subtract the 2, divide by 10 to give us the step height that we are going to subtract every year. In fact, because I'm saying F10 minus A1, that's actually a negative number. So we're going to add that amount. So let's go and see this happening. I've got this column here, you can see is called current value. And this column here is called long-term value. And so really I need the difference between the two. So my formula says, please take the value before, the L7, and please add to it the difference between my long-term value and my current value. And I'm going to do this in 10 steps. So let's divide by 10. So only do it a tenth of the value. And I can just copy that formula to the right. It's the same formula. Always that just changes. That's the cell before. But I'm always adding on a tenth of the difference between long-term value and current value. That'll give us nice sloped straight lines. So we are achieving this line to get from actuals down to our forecasts, and especially down to a normalized final year. It's really important because that F10, to calculate my terminal value, I'm going to take that forecast value, it's a forecast free cash flow actually, and I'm going to give it 1 year's growth, times it by 1 plus G, and I'm going to divide it by a cost of capital minus the growth rate, and that perpetuitizes it. Okay, and brings us every value from year 11 to year infinity, adds them all up, present values, and gives us back that value on year 10. We're going to do it for most of these. Most of these guys are going to work like this. Occasionally, there's one like a tax rate. This is a tax rate, 28% statutory corporate, and I'm just copying that all the way through. So I'm not doing any medians of tax rates. Let's look for another one. This one here is our cash and cash equivalents. This one is actually we want it as a minimum. We want to know what's the minimum amount of cash that we can get away with. And so I am using not the median anymore, I'm using Mr. Min. What's the lowest that we can get away with? And I calculate it immediately and I apply it immediately. No interpolation involved here. Just copy it to the right. What's another one? Surely there's another one here. This last one, debt equity ratio, not a minimum. I'm looking for a maximum. I want to know what's the maximum debt equity that we can get away with in the past, because that's what we will assume that we can get away with in the future. So I apply it here and then copy it forward. Just reference the cell before and copy right. Well, there's another piece that I should show you here, and that is, here's the median that I spoke about. But what's this X lookup part? This is referring to a sheet that we'll get to much later, the sensitivity report. And right now, if I press F9, you'll see that is adding 0. This is for us later to test how sensitive our model is to changes in inputs. So right now you can just leave that as 0, or you can put that in. But the important part here is if it does not find, if my X lookup doesn't find anything, it puts a 0. So that just works whether it finds if there's an error or not. Okay. So that piece there. The X lookup is only for our sensitivity, and you can leave it out for now. Right, there's another part that we haven't spoken about, and that is the sales growth. Sales growth is a big deal. Okay, we're going to be growing our sales rate, our growth rate from a 2% level up to a 4% level. And the way that it gets between there, okay, is to grow exponentially. So I've got an exponential growth formula. In order to get from there to there, I've got 9 steps. And so I take the prior sales growth in the cell before, and I multiply it by the terminal growth rate, which is the guy called 4 there, and I divide it by my initial sales growth, which is the 2. and I raise it to the power of 1 over 9. And that will give me the factor to apply over just 1 year. And if I apply that over 9 years, that will multiply out and it will get me perfectly from 2 up until 4. So I'm going to show you in another video how to do that, and especially how to add buttons, because I want to be able to click a button left and right, and I want it to change my sales growth basic. This guy here is my terminal growth rate basic. I've kept them separate, and you'll see it happening here. I want to know what happens. I'm going to use the formula bar up here. It just equals the cell above the 2%, but in my sensitivity, I'm going to be adding in a sensitivity piece for sales growth. And the same goes for my terminal growth basic. Here, it is just the cell in V2 above, the value 4%. But I'm adding in a terminal growth rate sensitivity for later. You'll see if I press F9, that just comes to a 0. So it's not working for now. Right, the important parts are in place. So you're going to get the medians going on down the bottom here. You're going to use a terminal growth rate basic at the top there, and you're going to refer to it. You're going to use a sales growth basic up in M2, and you're going to refer to it. That's that guy there. And to fill in the gaps between in an exponential fashion, not in a linear fashion, you are going to put in this formula here, which is takes your prior sales growth. Sales growth is the label of this whole column, this whole row, and you're multiplying it by the ratio of terminal growth rate divided by initial sales growth raised to the power of 1/9. And that will, after steps of 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, will get you perfectly from your 2 up until your 4. To reiterate, that is just adding the piece for the linear interpolation. There are a few here that you have to worry about, like the tax rate is constant. The cash and equivalence is just the minimum, which gets evenly applied. And finally, the max debt equity ratio is calculated and evenly applied. And now we have a good start on what our ratios, our forecast ratios, might be from a ballpark position. We're not putting too much or any of our opinion in at the moment. We're making sure that we are always trending towards what are normalized values, the normalized final year, so that when we do calculate a value from 11 to infinity, a perpetuity, we're not going to get any crazy numbers, because we have not allowed crazy numbers to come in from our current year in this column here. Right. How can we get into this bottom right hand quadrant? This is the part that we really need to get into. And so what we're going to do is, because all these are labeled, we can now say, I tell you what, let's take the prior sales. Yours might be called turnover, mine is called sales, you can see on the right. And it's going to refer to this number here, the 25 billion. And the way that we typically understand is that we should take last year's sales and multiply by our sales growth. That sales growth in this case would be the 2%, this row here. That's fantastic. But what happens if our prior sales was not done over 12 months? It was over 9 months, 15 months, because of a year-end change. What are we going to do there? Well, what we're going to do is we're going to go and calculate what period were those prior sales calculated over. And we know that if we go and we calculate we go and get the prior date, that was the end of year for the prior sales, and we subtract the end of year, okay, 2 years back, we can get the period. the period that those were calculated over. I press F9 here. If I press F9, no, that doesn't like it. I was hoping to actually get a calculation there, but that will typically is going to give me 365 days, usually. Okay, and that's why, because it's a number of days, we're going to get sales per day. And so it's important then to multiply by the 365.25 to turn the daily figure into an annual figure. And only when it's annual, can you then multiply by your sales growth, which up here you haven't said so, but it's implicit that your sales growth figures are per year. If you do that correctly, you'll see that it's typically, I can even show you that, divided by that, minus 1, and hopefully we are going to get the 2% that we're talking. Why isn't it exactly 2%, you ask? Well, it turns out that I was using it's probably 366 days at the moment, because we went over a leap year, but I've only annualized it by 365 and a quarter days. That's why it's not exactly. Okay, but that's that 2% there is that 2% there. Now for the clever part, you can highlight across here and press Control R, and it will copy your formula all the way through. Same formula all the way through. Typically the prior date 1 and date 2, which you've made sure aren't going to make a difference up here, because it's always going to be a 12-month year. So we've just started our model. That's very cool, because now we can, wow, do you think we can put in some extra things? Well, there's your turnover. You can say at turnover, and guess what? You have got cost of products as a percentage, so you can just multiply. So it's as simple as multiplying those two together. Sales times cost of sales. So if there wasn't anything there, Excel doesn't like me doing this. I should have turned calculation off. You can see it's running in the background down the bottom here. Iteration 63 thinks I'm quite mad. Why would I delete my sales? I'm going to go Alt MX M to turn it off, and I'm going to say sales minus cost equals at sales, and I want to take a proportion of that, and it must be the costs. It must be that one there. Press Control Enter, and I'm in. Right. Is that all it is? How do we calculate gross profit? Sales minus COGS. How about selling? Sales times your selling line. It's really, really easy. EBITDA we know is sales minus your overheads minus your cost of sales. That's your EBITDA. Earnings before interest, tax, depreciation, and amortization. Let's try a more interesting one. We've got a depreciation percent. That's this guy here. That's like 6%. Just press F9, Control Z, and I'm going to apply it to my guess what? My opening balance of property. This is your land, etc. And I'm going to add that to my end of year, and I'm going to divide by 2 to get the average, and that should give me my average expected depreciation in that year. Copy the formula to the right. Operating profit, EBITDA minus the depreciation, interest and finance charge. Well, what is it that causes interest and finance? It's your long-term debt, opening and closing balances, short-term opening and closing balances. Divide by 2 to get the average, and finally multiply by your cost of debt. So somewhere up the top right there, I've called it cost of debt. See it all happening. Similarly, for any cash we might receive, we've got a return on cash, and I'm going to multiply it by my average money that sits in my cash and equivalents, earning interest. I can Yo-wee, look at this. Look how cool this is. Sales minus cost of the sales, minus depreciation, minus SG&A, minus interest, and importantly, plus the interest income. Now I've got my earnings before income tax. Do I have a tax rate? I do. I can multiply my tax rate by my earnings before tax. Profit after tax, this is the important one, EBT minus the tax. Very straightforward and always copying to the right. Profit for the year. Okay, we don't have discontinued operations, so that will stay exactly the same. And I'm going to stop us there. I'm not going to talk about the dividend just yet. That's another thing, but I am going to talk about the retained earnings, because the retained earnings is the difference between our profit after tax and the dividend that's paid out. So I'm paying out a dividend. In this case, I'm not. So I am actually a bit short for cash at the moment. You can see I'm not going to pay any dividend, and I've actually got some losses that are going through. So my balance sheet is suffering. I'm taking that through. Retained earnings has to end up on the balance sheet. I'll show you where it ends up. It's on distributable reserves, this line here, distributable reserves. And you'll see that there is our retained earnings coming from the income statement and being added on to last year's number, last year's cumulative retained earnings. And that's how your balance sheet equity grows. So I want you to see if you can fill out, get this top part, forecast ratios going that end up in that nice normalized column at the end here. And then I want you to see if you can take it through and build up your income statement from sales and turnover all the way down to retained earnings. When we come back, we will be starting the building of the balance sheet. Not too difficult, but some interesting things are going to happen. Turns out that when we calculated, whet your appetite here, when we calculated our interest charge, we were using long-term debt and some short-term debt, etc. But these don't exist yet. We haven't built them up down the bottom. They're zero. They don't exist. So how can this work? If I abandoned here and went to the bottom to fill them in, well, I wouldn't be able to calculate them down there because I wouldn't know the effects of my cost of debt. So we have a chicken and egg situation, a classic catch-22. And Excel is really good at managing this. It says, don't worry, just put it in. And if I see that, I'll just make a guess at what it is. When I actually calculate what it is, my long-term debt, I'll come back here and I'll recalculate this. I'll go round and round and round until it all settles down. And that's called an iteration. It's called a circular reference, and they are good. So this is the very first one that we're going to encounter. Right, when I see you next, we are going to unpack or pack up the balance sheet. We're going to start with calculating the assets. Right, hope you enjoyed that so far. Good luck, and send Mike and I questions.